Hello everyone. This video is kind of a summary of certain sections, and I'll put on the title, we'll see how far I get, but on the title it'll tell you which topics are in this video. So my guess is it'll probably be topics 1 through 3. So topic 1 is just really function basics. A lot of this you learned in Algebra 2, but it's just, can you identify a function versus something that's not a function? And so a function is something that has one output. So every input has one output. And therefore, these were like, it doesn't pass the vertical line test on this graph because there are multiple outputs up here and down here for each of these input values. So the x values are repeating, and they have 2 output values, and that's not allowed for a function. And so here are different examples of this. So if you're looking at a mapping, every x is going to one y, but this x over here is going to multiple y's. In an equation situation, normally y is to the first power, and x can be multiple things, but whenever we change this to y being squared, our graph is going to look something like this. And so when y is being squared, or when y is in the absolute value bars, it's now turning that graph sideways and making it not a function. And so here's some examples of this. Here the x is squared, that's a function. Here y is equal to 3, that's a horizontal line through the y-axis, that's a function. X is the first power, y is the first power, this is a linear function, that's a function. Y is to the first power, x is the square root, so this is a square root function, that is a function. But then when we get to this one, the absolute value bars, or if this was squared, the y being inside of either of those things is going to cause a problem for us, because now that graph is turned sideways, and so now instead of it being a quadratic function, a U shape or a V shape for our absolute value, now it's sideways, and we won't pass the vertical line test. And then same thing on this one, the y is being squared. So both of these would not be considered functions. The other thing that we see in topic 1 is evaluating a function. And so hopefully you see here the highlighted blues. G of x is now g of 2. We are taking out every single x in this equation, and we are plugging in the value of 2. And then we're just doing the math and solving for that y value. So the x value is my 2, the output value on this one is also 2, but the output value is the y value that you get when you plug in a specific x value. And so we're just evaluating. And I don't think on ours, no, I'm just looked. Ours is just numbers, so I'm not having you guys plug in any variables like we did earlier in the semester. Okay, the next section is parent functions, and so this is just your list of parent functions, and so as you're identifying which parent function is which, hopefully this table is helpful for you. You should have put this in your notebooks, and we've also added some new functions this semester. So the sine function and the cosine function could also be added to this information. That is a function that we've talked about this year, and so that could also be tested, and that also shows up on your review. And then moving on to topic 3, we also have domain and range. And so the big topic that we could see here is like which functions have all real numbers as their domain. So like the constant function, the linear function, quadratic function, absolute value, cube root, cubic, all 6 of these have a domain of negative infinity to positive infinity. But square root and rational are going to be our problem children, and so the square root function cannot have any negatives, and the rational function cannot equal 0. So the denominator cannot equal 0, and this one underneath the square root needs to be a positive number. Therefore, x is greater than or equal to 0. So the way this plays out in our domain is we take whatever is underneath the square root, x plus 3, and set it greater than or equal to 0, so that when we solve minus 3 to both sides, x is greater than or equal to negative 3, and that would be my domain. So this would be in inequality form, and this would be in interval notation, negative 3, square bracket, because it could be equal to positive infinity. On rational functions, or reciprocal functions, we can factor whatever's in the denominator, set that equal to 0, or really not equal to 0, because the denominator, that's our problem. And so when we factor this, it turns into x minus 3 and x plus 5. So then both of those factors are set not equal to 0, so then therefore x cannot equal 3, and x cannot equal negative 5, and so those are the two values that are left out of our domain. And so hopefully this is a reminder to you how those domains are written: negative infinity to negative 5, union with negative 5 to 3, union with 3 to infinity. So in the next video, we'll talk about the next topics.